Okay, next we're going to set up a proportion for these word problems and then solve the word problems. So we're going to need to set up a fraction equals a fraction, or a ratio or rate equals another ratio or rate. So if 5 oranges cost $1.15, what will the cost of 15 oranges be? So we're going to let x equal the cost, the thing that we're looking for, which is the cost of 15 oranges. It's always important to write down what your x is so that when you solve you have a complete solution for the reader to understand what x is supposed to be equal to. Now we're going to set up a proportion. Now we have two things going on here. We have cost and we have the number of oranges. So it doesn't really matter which one you put on top, but I'm going to put cost on top and oranges on the bottom, and I label that. Okay, then I have a fraction equals a fraction. So if 5 oranges cost $1.15, the cost is going to be $1.15 per 5 oranges. That goes on one fraction because these two are related. The 5 oranges are what cost the $1.15. Then we have another number. What will the cost be for 15 oranges? Well, where should 15 go, on the top or the bottom? Well, it belongs on the bottom because oranges is on the bottom, and that's what 15 is. What is the cost of this oranges? Well, we don't know, so we put it x. That's where our x comes. The cost is going to be on the top, the oranges are on the bottom. Now I have a proportion I can cross multiply and solve. So we have 5 times x, which is 5x, equals 1.15 times 15. You want to get out your calculator for this one. So that's 17.25. And then I'm going to come in and divide both sides by 5 to solve for x. And that gets me x equals, take out your calculator, 17.25 divided by 5 is 3.45. So don't write x equals as your answer. We want to go back to the question. What was the question? What is the cost? So the cost better be in dollars. So $3.45 is the cost of the 15 oranges, which kind of makes sense, right? Because 15 is more than 5, so the oranges should cost more than $1.15. It should be more than that, which is what our answer is. Our answer is a lot more than $1.15. Next problem, we're talking about Donnie and Marie are planning a backpacking trip. In their map legend, the legend indicates that 1.2 centimeters on the little map represents 2 miles in like the real world, okay? So how long is their trip if the route measures 10.6 centimeters on the map? And we're rounding to the nearest tenth of a mile. Let's see. So we have let x equal the length of their trip, okay, the actual length of their trip. And we're going to set a proportion. We have centimeters and we have miles. Again, it doesn't really matter which one you put on top, just as long as you have them labeled and that you put them in the correct spot. So let's read this problem again. On their map, the legend indicates that 1.2 centimeters, so that's 1.2 is going to go in the centimeter, which I put on top, represents 2 miles, so that's going to go on the bottom. Let's keep reading. How long is their trip? I don't know if that's going to be x if the route measures 10.6 centimeters on the map. So 10.6 centimeters should go on the top because the centimeters is already labeled for the top, which means x has to go in the bottom. Now I can solve this by cross multiplying. 1.2 times x is 1.2x. 2 times 10.6 is 21.2. Now I can easily divide both sides by 1.2. This would be the time you might want to get your calculator out. This gets us x equals 17.6 repeating miles. So 17.6, that means 17.66666 repeating. Now if we're rounding to the nearest tenth of a mile, that's right here where the 6 is. This 6 tells it the previous 6 that we need to round up. So 17.7 miles is the correct answer rounded to the nearest tenth. I'd probably be okay if you rounded it, if you didn't round it all and just gave it to me in exact form. that's probably going to be okay. But this particular problem tells you to round to the 10th, so I did that. Our next problem is about making cookies. So a recipe making 2 dozen cookies requires 1 3/4 cup flour, among other ingredients. If the baker wishes to make twice that number of cookies, how much flour is needed? Okay, so we're looking for let x equal the amount of flour, and I believe we're talking about it in terms of cups. Okay, so go ahead and just make that definition so we all know what x is. We're talking about two different things. We're talking about flour in cups, and we're also talking about like the dozens of cookies, right? So for 2 dozen cookies, I use 1 3/4 cup of flour. If the baker wishes to make twice that number of cookies, so initially we had 2 dozen cookies. What's twice as much as 2 dozen? That's going to be 4 dozen. How much flour? Well, we don't know, so x is going to be the flour. So now I can cross multiply. 2 times x is 2x. 4 times 1 3/4. So if you need to get out a calculator, you might consider using, instead of 1 3/4, you might consider writing 1.75, because 3/4 is the same thing as 0.75. So 1.75 in your calculator times 4, and then hit enter in your calculator, and you're going to get 7. Now to solve for x, I'm going to divide both sides by 2, and that gets me x equals 7 halves. 7 halves is a perfectly good answer, although we could write it in mixed numbers. 2 goes into 7 how many times? 3 whole times with 1 left over. So 7 halves is the same thing as 3 1/2. So you could either write 7 halves cup flour, and that's totally a perfectly good answer, or you could write 3 1/2 cup flour. Now usually in baking or in cooking, you'd probably use 3 1/2, because you have to actually take your measuring cup and scoop 3 cups of flour, and then you have to take a half cup and get another cup. So probably 3 1/2 might be preferred, but either one is fine. Next, we're going to be talking about percent. So percent means parts per 100. That's what percent means. In fact, the word cent here means 100, so percent means per 100, or out of 100. So let's say an example, we have 100 people in our survey, and 17 of those people drove blue cars. Okay, what percent drove blue cars? Well, that would be 17% drove blue cars. That's the symbol for percent. Okay. What percent did not drive blue cars? Well, if 17 people did drive blue cars, if you subtract that from 100, that is going to get you 83% did not drive blue cars. Okay. And this is really easy because it's out of 100 people, so percent. We're going to be looking at more surveys much later on in the course, which has not out of exactly 100, so the percent's going to be a little bit more difficult, but for now, I'm just trying to introduce the word percent. So let's say 46 out of every 100 college students live at home. What percent of college students live at home? 46%. How many don't? Well, if you subtract that from 100, you get 54%. All right, now we need to know how to change percents into decimals, and then write also decimals as percents. When we are writing percents as decimals, it's simply you're going to move the decimal place 2 places to the left. So your decimal point is right here behind the 7, because 87 always has a decimal right after it. Any whole number has a decimal right after it. So if I move 2 places to the left, that's now going to be 0.87. So 87% is the same thing in decimal form as 0.87. Let's do it again. 1%, if I move it over 2 places, I'm going to fill those in with zeros and move the decimal there. That's going to be 0.01. Again, on 230%, move it over 2 places. That's 2.3. Notice this is more than 1, but 230% is more than 100%. So it may be uncomfortable to see that, but 230% is a perfectly good percent. Just means we're growing quite a bit over the where we initially started. So next one, move the decimal over 2. That's 0.578. The next one, move the decimal over 2 to the left. Any spot that's empty is going to be filled in with a 0. So the 0 in the front, then my decimal point. Then we have 1, 2, 3 zeros and a 4. And then the last one, 100%, move the decimal over 2, and that gets you 1.0. But no one writes 0.0, it's really just 1. So 100% is equal to 1 in decimal form. Now, writing decimals as percents is the exact opposite. You're going to move your decimal place 2 places, but this time to the right. So 0.38, move the decimal, that's 38%. One 1.25, move the decimal 2 places to the right, that's 125%. 0.6, move the decimal over 2 places. Anything that's empty is going to be filled in with a 0, and that turns into 60%. 0.65 is going to be 65% when you move the decimal over. 0.012, move the decimal over 2 places, that's 1.2%. And then move the decimal for 1 over 2 places, fill it in with zeros, that is going to be 100%.